Good afternoon. Happy Friday, everybody. Today is going to be the next segment in our AV over IP offering. This one's going to be on IPMX, hosted by Panasonic. It's another open standard for AV over IP. What I like about open standards is then, everything's compatible to a point. So with that, today we're going to have Keith. I'm probably going to slaughter your last name, Keith Vidger. Did I get that
That's
anywhere
exactly right.
close to right? Keith is going to be giving us the how their approach to IPMX is, and I'll be monitoring the chat if anybody wants to throw in a question, and then we'll open it up for questions at the end. With that, take it away, Keith.
All right, thanks so much. I'll share my presentation here. Hello, everybody. Okay, hopefully we can all see the PowerPoint that we'll be looking at for the next, we'll say 40 minutes or so as we discuss the exciting capabilities of IPMX. We, of course, want this to be interactive, so we'll certainly have a Q&A session at the end, but if there's anything that really is a burning question or something you want immediate clarification on, feel free to chime in and we'll do our best to answer that on the spot. If not, we'll go through a fairly brief presentation that covers what cool things are in IPMX, why it is a thing, even in the first place, who invented it, and what is addressed by IPMX that is, we'll say, perceived to be lacking in the world today. So with that, we'll jump right on in. But I should probably introduce myself, I suppose, that as a couple of folks from Panasonic are on the phone today to support this cool event. My role at Panasonic is as the engineering manager for the professional products. So everything from studio cameras to switchers and PTZs and lots of other cool things, microphones and whatnot. It's a great role that allows me to work with amazing technology and lots of great people such as yourself. So part of that interaction with technology is how one product connects to another. And certainly IPMX is one of those interfaces that's becoming popular, and obviously people want to know more about it. So happy to be able to share our collective wisdom, if you will, about IPMX and where it came from. So let's go ahead and go on into it. So first off, let's get rid of the, we'll say, the textbook answer on what IPMX is. So of course you can see the full definition there, the Internet Protocol Media Experience and set of standards. Ames is the one who created them all. It's really not that old, just 5 years in the grand scheme of things. So the new kid on the block, if you will, when it comes to all of the various standards that are out in the world today. And if we want to drill down just a little bit deeper, essentially we can think of it as a subset of ST 2110. So we're going to get into that in just a little bit, but essentially it's not really thought of as much as being a standalone, but again, part of the SMPTE 2110 suite of standards. Okay, so let's do my favorite thing, which is talk about the backstory to help us understand where something came from. And that, of course, hopefully helps us better understand how it might come in handy for us, how we might better use it. So let's go all the way back to the late 80s. That's when SDI was created, 1989 to be precise, largely for broadcasting, and a industry standard to this day. Different versions, HD SDI and then 12G, and there's some other ones in there and all that kind of good stuff. But ultimately, broadcasting had this new digital kid on the block way back in the late 80s, and it's super cool, where the AV industry still essentially used a collection of analog interfaces. Composite, we probably all have seen as video at some point, and there is the components, the three-wire cables, and if you throw in the fact that audio is always a separate signal, not super convenient. And boy, if you really go back, you might remember 8-pin block connector cables and a variety of things, all with the same goal, trying to make things easy. Having a collection of different cables for everything from reference to, we'll say, video, and then audio, and in some cases control and time code, and it's just so much stuff. So it wasn't easy to be in the analog world back in the 90s. And when SDI came out for the broadcasting world, it said, wow, they've got their new cool kid on the block that really didn't have a correlation to the AV world. So flashing forward just a little bit, then we'll say 10 years, in fact, the late 90s now, HD SDI, obviously high definition serial digital interface, created for the broadcasting world. And then finally, just a few years after that, in the early 2000s, now we have HDMI. So, yay, HDMI. HDMI is super cool. It's for the first time, we're able to kind of shed off all of the analog interfaces and finally have something that's easy to connect one device to another. It, of course, gives us the ability to not have to have a whole myriad of different cables for audio and all of that sort of thing. So, super nice in that regard. But not only was it nice and finally kind of caught up the AV industry to what broadcasters have been used to with HDSDI, but it had some cool things that HDSDI did not have, most notably bidirectional communication. You might know or thought about the fact that when you plug in an SDI cable from, for example, a camera to a monitor, the signals just go one way. It goes from, of course, the camera to that monitor. There's no feedback whatsoever. There's no content headed back in the other direction towards the camera. But HDMI is different. As we, I'm sure, all know by now, there is a bidirectional communication that allows things like EDID and HTCP and some other cool things. So for once, HDMI seemed like it really took it up a notch and allowed the AV world to essentially catch up to, and in some cases we could say usurp even the broadcasters because of that great bidirectional communication, making our lives easy because again it had EDID, making us compliant because of course as content creators we want to both appreciate and respect the need to protect content. So while I'll say our good old friend HTCP doesn't always make our life easy, I think certainly the idea that it's important for the world we work in is certainly there. So yay, HDMI is cruising along with great things. And again, even took it up a notch from the standpoint of ultimately signal quality. You could do things like 444, whereas the broadcasting world is usually limited to 422. You could do 12-bit, whereas again, broadcasting largely limited to 10-bit. So pretty nice that HDMI, and of course, all this didn't happen immediately, but HDMI has evolved and it's got some great things. Obviously 12-bit, or I should say 12G signals, forgive me for stumbling there, are very much a capable or a thing that's common these days in the world of HDMI. So just as HDMI has evolved over the years, of course, HD SDI or SDI in general has evolved over the years, and they've sort of paralleled one another. So all super cool in that regard. And really for 20 some odd years, the HD SDI connectivity, we'll call it simplistically, for the broadcasting world and HDMI for AV, essentially were the only game in town, if you will, and they effectively helped the respective industries. And of course, the further things went down the pike, the more crossover there was. HDMI is used in broadcasting for all different kinds of applications, most notably displays. Of course, SDI has gotten inexpensive enough that it can be used in just about every application in the AV world. So loads and loads of cool things that relate to the idea of how these things have gotten used together, all the good stuff that we would expect from both standards. I wouldn't say crossed over or became one, but certainly the idea that they're closely related, if you will. All right, so it seems like everything's great. What more could you possibly want? Everything is said and can't be better. Well, as part of this backstory, a lot of folks, if we think about just the SDI world, have been kind of clamoring for improvements to it. Once again, we noted just a little bit ago that SDI is a suite of interfaces, unidirectional, that only send signals in one direction. So that wasn't super cool. And so there was a desire to have something better. And that's where SD2110 came along. Not a replacement, if you will, for SDI. I don't know that there will ever be a true replacement for SDI because it's just so easy and all that. But it had some drawbacks to it. Number one, as we just mentioned, you don't have bidirectional communication. Number two, the cable lengths are, in many cases, generally limited. You might say, well, I can get 1,000 feet out of SDI, but if you're 12G, it might not be that long. And boy, the cables get pretty big and hefty when you're trying to transmit 12G over SDI. And so nowhere near the incredible length that you would get from a 2110 environment where you could have literally miles of length. And of course, SDI is over copper, which can kind of be expensive. And uh, the IP-based world of 2110 fiber-based connectivity, not nearly as expensive. And in the SDI world, you need big, expensive routers. If you were to go to any, we'll say, broadcasting environment, the TV station, and say, what's the single most expensive thing you have in this building? In almost all cases, they'll point to their giant router. Not uncommon for routers to be $1 million in cost, especially if you get up to the big size. So there was a desire with 2110 to improve upon, we'll say, the limited cable length, the lack of bidirectional, the fact that routing was pretty expensive, and therefore it'd be great if you could use commercial off-the-shelf switches or COTS switches. Lots of great things about why 2110 exists in the first place. So if you've been delving into the world of 2110, I'm sure you found all kinds of cool things. Not to mention all the things about individual streaming, so you don't have to de-embed an SDI signal to extract its audio. It exists as its own stream in 2110 and can be siphoned off, if you will, right at the switch to audio mixers at different places. Loads and loads of cool things about why 2110 has great benefits over SDI. However, what 2110, despite all of its cool things, did not address is it doesn't have all the cool kind of things we've become used to with HDMI. HDMI has all kinds of neat things that, as we enumerated, the simplicity to it, the EDIDs and the HDCPs and all kinds of stuff. So we love all those things. And, 2110 doesn't really have all that stuff. So now we can think of the 2110 world, again, for broadcasting, HDMIs for AV. Man, if only there was some cool IP-based version of 2110, or I should say, really, an IP-based version of HDMI that's related to 2110, a cousin to it, a brother, that kind of a thing that gives us all the benefits of 2110 and all the benefits of HDMI. We, of course, all remember, or maybe remember that little commercial where somebody inadvertently put a chocolate bar into peanut butter, and from there is where we had Reese's peanut butter cups and all that stuff. This is the same idea. We've got somebody walking down with an HDMI cable and a 2110 connectivity on the other side, and they bump into each other. And what does that combination of two things get us? Well, that is going to be IPMX. So IPMX is basically all the cool stuff of 2110 plus all the cool stuff of HDMI all kind of put together. So if we think about, all right, what really makes HDMI? Well, again, simplicity and all that. We love those HDMI cables. There are probably a trillion HDMI connectors on displays throughout the world. There's EDID that makes HDMI cool. There's HDCP, and no need for something called PTP. If you've been going down the path of 2110, you'll realize that the modern version of reference in the 2110 world is something called Precision Time Protocol, or PTP. And PTP, while super important and necessary in the world of 2110, can sometimes be a little daunting for some folks who don't have exposure to it previously. Reference is generally pretty easy to get your head around and all that. And PTP is better in a lot of ways, but initially it might seem a little daunting to get into. So not having to have PTP would be kind of a cool thing. So now that we've got the basic idea, thanks for indulging my backstory there about where IPMX came from, what is really IPMX? We kind of delve down deep into it now. What do we have there? All right, so what do we get out of IPMX? What does it support? Well, number one, we have embedded audio. As you might imagine, just like in the HDMI world, audio, of course, is an important thing for a single connectivity-based format, so we want that. So embedded audio is in there. It's based on AES67, just like it is in the SMPTE 2110 world. And it has embedded ancillary data. So now we can pass information just like we would in the 2110 world. And one thing that generally people don't associate with the world of ST2110 is compressed video. Most of the time we think of both SDI and 2110 as being uncompressed, the best quality, no latency, or at least the least amount of latency possible. And yeah, we love that. But there are certain applications where, I'd really like to get some mild compression in there for certain applications. A quick side note about the world of 2110 is that, again, it uses the commercial off-the-shelf networks, things again not necessarily invented for the world of video. So in a correlation, we'll say, to the standard world of SDI, you've got routers that are capable of, we'll say, 1.5 gigabits per second, again, invented specifically for video. And then there's 3 gigabits, and then you go up to 6, and then you go up to 12. So these products that are these routers, once again, mentioned that as being very expensive devices, if you have the huge ones and TV stations and whatnot, they are custom built for video. As a result, they're kind of expensive, and effectively, there is a direct correlation to what they're capable of, 1.5 gigabits, 3, 12, that sort of thing, and the standards that they support, all the HDSDI flavors that we know and love today. But in the world of 2110, the goal was to essentially not burden, we'll tie the need to do bigger routing infrastructures to conventional video routers, not to burden us with that cost that comes with building, maybe big video routers. They might make 100 or 200 a year. And of course, that means they're generally very expensive. So if we use commercial off-the-shelf products like conventional switches, then we get the benefit of, we'll say, having something that's pretty inexpensive that we can use. But because it's not meant for the broadcasting world, or AV for that matter, then you can say, well, now we're kind of stuck with, if you want to put it that way, the standards that exist in the general networking world. For example, the data rates aren't 1.5 gigabits and 3 and 12. Of course, I'm leaving out a few to shorthand it. But instead, in the IP world, they are 1 gigabit, and it goes to 10, then it goes to 25, and it goes up to 40. And you can say, wow, 10 and 25 and 1, those don't sound like they very much align with the video world. Of course, you're right. They don't. They were invented for the IP world, not the video world. So then you're like, all right, so if I need to do a 3 gigabit video, can I use a 1 gigabit IP connectivity? Well, no, it's obviously not enough. All right, so then I have to go from 3 gigabits, which is my signal, up to the 10 gigabit IP standard. Yeah, that's kind of what you have to do. Okay, well, I've got 12 gigabit video. Where do I have to use the RAT? Well, now you have to jump up to 25 gigabits. Ugh, boy. So that lack of alignment means that I'm coming so close, for example, with a 12 gigabit signal to be able to put it into the 10 gigabit world in the IP world, or the IP way of doing things, we'll say, but it's just not there. We need just a little bit of compression, hopefully lossless compression, visually lossless compression, that essentially allows us not to have to essentially jump from a 10 gigabit infrastructure, which might be perfectly suitable for our needs, but it just can't handle 25 or a 12 gigabit video, and therefore we have to jump to 25 gigabits in the IP world. So compressed video would be handy for us. So compressed video, there's different flavors that IPMX supports, but one of the big ones would be JPEG XS. Mildly compressed, and again, notably, and most importantly, we'll say for a lot of folks, getting those 12 gigabit signals that we would have in the, call it the traditional HDSDI world, just under the 10 gig limit, so it's able to be handled by a 10 gigabit switch, 10 gigabyte, or 10 gigabit, SFPs, all those kinds of things. So some mild amount of compression is a cool thing that we would like in the world of IP video, and JPEG XS and some others allow that, and IPMX supports that. So sorry for the very long-winded story there about the goal of having compressed video in the IP world, but it does come in handy in certain situations. But ultimately, it means that IPMX supports, we'll say, both uncompressed and compressed video. So IPMX can do both of those things. And another thing that we're pretty much used to in the world of HDMI, it's non-standard resolutions. So typically, if we think about the broadcasting world, there's only a handful really of standards when it comes to resolutions. There's, 1920 by 1080, and of course 720, and then there's 4K, truly 4K, which is 4096. But that's not really a broadcasting standard. So we have UHD or 3840 by 2160. Again, a relative handful of resolutions exist in the broadcasting world. But when we think about AV, holy cow, there's so many different resolutions. I mean, all you have to do is look at a collection of monitors in one room, and you'll see there's probably no two monitors the same size. Everything from plain old 1920 by 1080, but to double wides and triple wides and a myriad of other sizes in between. HDMI in a single connectivity mode from your, we'll call laptop to a display or whatever it happens to be, one cable. gets it done. The EDID makes it understood by the display to the source, what it needs to be, and boom, don't even have to do anything. Super nice. If you've worked with SDI long enough, you probably realize that if I send a 24p signal at 720p to a display that's expecting 1080 and 30, it's just not going to show up. There's, again, no communication between the two to essentially make the output, the sender, change what it's sending. It just sends what it sends, and you have to go to the display and configure it. So having, number one, EDID, super cool, and number two, support for non-standard resolutions is also cool. So all that to say, in the true SD2110 world, or the one that most people think about, you have just a small set of resolutions that are supported. But IPMX supports non-standard resolutions. So definitely a cool thing for use in the AV world. And as you might imagine, there is, again, a limited set of things we have in the broadcasting world. Touched on just a little bit ago, 10-bit 422 almost entirely. And we have all kinds of cool things in, let's say, the AV world. Everything from 12-bit and 10-bit. In some cases, a lot of cases, there's 8-bit. There's 422, there's 420, there's 444, 4444 as we're showing here. A whole myriad of different things, largely based on the fact that we've got whole cool collection of displays that can do great things, and there's content that can be played back to essentially match that. For the most part, not generally something that we would do in the 2110 world, but IPMX once again supports that. As we said before many times, EDID is supported by IPMX and, again, HDCP. So all the things that we're used to in HDMI, we'll say, now essentially supported by IPMX. So a lot of cool things in that regard, and a lot of compatibility, if we want to think of between the world of HDMI and SMPTE2110, but not the least of which is the actual connectivity itself. So if we think about, once again, 2110, well, all kinds of connectors. There's fiber, there's dual fiber, there's bi-directional fiber, you have SFPs, and of course you start going up, there's 40 gigabit infrastructure, there's 100 gigabit, it goes up from there. So lots of fiber-based connectivity and things of that nature. Certainly some copper-based cables in the IPMX world, but they're, in the 2110 world, but they're all based around, as we said before, the typical IP industry. Nothing really meant for video. Again, it's just being adopted, that whole COTS concept, the commercial off the shelf, just being adopted because that stuff already exists in huge numbers, and the result is inexpensive to use. So all that is great. But what if I wanted to use the HDMI connector, mostly because, again, there's a bajillion displays in the world, not to mention sources and things of that nature that have the HDMI connector and only the HDMI connector. So what if I want to use those things but get the benefits of, say, SMPTE2110? Because, again, it's streaming, it can go through switches, huge, long cable lengths. As we all know, one of the things that's not so great about HDMI, relatively short cable lengths. And then, of course, if you need to go to longer cable lengths, which don't even get that long, 100 feet and things of that nature, you have to go to active HDMI, then it becomes a one-directional cable and all that stuff. So it'd be cool if HDMI, that we know and love, could be taken up a notch, if you will, and incorporate the fact that it can go long distances, it can go through a switch, and all those kinds of things. It can be routed and get all the benefits we've talked about here, and all that would be great. But at some point, I still need to plug that HDMI cable into the back of something, for example, a display. So IPMX supports that. Okay, so an awful lot of detail in a short period of time there about where IPMX came from, why it was invented, how we get to use it, that sort of thing. Before moving on, I wanted to talk, or we'll say quickly pause here, and this is where I'm going to ask our friends who've been looking at the chat here to relay those questions, so we could do a quick Q&A before moving on.
Yeah, Barry had mentioned to RGB HV for computer graphics. Barry, what was that in relation to? Using IPMX for doing that? Maybe Barry stepped away. I say keep on going, and we'll keep monitoring the chat if something else comes up.
Okay. So, one of the things that, again, most liked about the idea of, we'll say, the 2110 world, one of the reasons why it was invented is the idea, again, that we have separate streams that happen to be on a single cable. So we think of it as, all right, I've got audio, it's its own independent thing, video, it's its own independent thing, ancillary data, all those are independent streams within the cable. You can kind of say, well, it's kind of the same as HDSDI or SDI, right? Well, similar, except that in the, and this is where sometimes my favorite saying about trying to learn things in an industry comes into play. And there's one thing has 10 different names, and 10 different things all have the same name. So uh, in the conventional SDI world, we have the idea that things are packetized. We put all these different signals, audio, video, ancillary data, all that kind of stuff into a packet. That packet goes down the SDI cable, gets to its destination, and is unpacked. Which means that if I wanted to send SDI signals into a video router and extract audio from that, because the audio is there, it's not going to work because the router, generally speaking, doesn't have the ability to de-embed the audio from the signal or re-embed for that matter. So you have to have that done outboard. Outboard embedders, de-embedders for audio, as an example. So not exactly super elegant right after you spend a ton of money on your big fancy video router. But in the 2110 world, they exist as separate streams. So put that cable from your source, which has audio, video, ancillary data into the switch, and now someone can peel off or take, extract, if you will, just the audio, and that comes out of another port of the switch. No de-embedding necessary. So one of the great benefits of 2110. That also exists in IPMX. So now we've got the idea that unlike HDMI or SDI, where things are all packetized, we can essentially siphon off just the part we want and it can go somewhere else. So neat in that regard. But it also means, in comparison, or we'll bring it up as the only real downside to IPMX, is that things have IP-based addresses. So normally we think of SDI, I've got a camera, cable in the connector in the back, plug it into a connector on my monitor, and it's done. One cable, two connectors, anybody could do it. Turns on, instantly you're there. Yay, it's great. HDMI, same idea. HDMI out, HDMI in, boom, done, love it. Okay, so super easy, but you got some downsides. Number one, how do you take off individual elements? Of course, HDMI doesn't want you to separate out the audio and the video and things of that nature. It wants to keep it all together, but it doesn't always make our life easy in the production world. So in IPMX, we assign the audio a particular stream ID, 2786.40.30.10, whatever it happens to be. And we assign the video its own ID. Ancillary data has its own ID. So we assign IP addresses, if you will, to the various sources and knows the senders and the receivers likewise and things of that nature. So we now go to the trouble, if you will, of putting in these individual addresses. If you've got, say, 10 sources, then of course each one has to have its own unique address, and then the audio has to have its own unique address for the 10 senders or 10 sources, cameras, servers, whatever. So all of that has to be done. So that concept of I'm just going to plug in my HDMI cable here and there and call it done. You can do that, but it won't work until you start putting in those IP addresses. So I'm bringing this up as while there is a ton of great stuff about IPMX, and there's a ton of great stuff, of course, about 2110, there's a little bit of effort that's required on your part. Now, to use an infomercial term from the 80s and 90s, it's the set it and forget it. So once you put in your IP address, your stream IDs and all that kind of stuff, you're basically done with it. You don't have to do it again. So you do have to put in that effort at least once. And then that connectivity, again, the streaming signals going through switches and different destinations, all super cool, all great. So there is a tax to pay, if you will, in terms of your effort where you need to identify all the various audio, video, and ancillary data streams before you can start routing them different places and making use of them and getting what's known as the multicast addresses going and all that. So a little bit of effort, but you can definitely reap the rewards once all that little bit of effort is done. And now essentially have a much more developed network with much more flexibility and all that. And ultimately, of course, it all gets put back in together as one signal going down the pipeline via the HDMI cable itself. So just to reiterate, well, it's a networking-based solution in terms of IPMX, just like 2110. We think about fiber cables, things of that nature, and again, traditional switches, at some point it can go back into an HDMI cable. And that actually brings up our next point of discussion. So in general, we think of this as an IP-based infrastructure in the world of IPMX that does all these cool things. And at some point, though, you now have an HDMI cable that will plug into your display. And that's really the heart of it. One of the digs, if you will, about 2110 is that for all its benefits and adoption on the source side, loads of cameras in the professional world, as you probably know, switchers, all kinds of great things, all cool for the world of 2110, not so much on the display side. So if you go looking for an SFP cage on the back of a lot of displays, you're just not going to find them because they're just not quite there yet. But of course, without exception, you will find HDMI connectors on the back of displays. So really, HDMI, that physical connector itself, is still needed to get all the benefits of what we talked about all the way down into a display. Because if you do all this stuff, but you can't see it, kind of what's the point? So to have displays, whether they're on set monitors or just multi-viewers or there's just getting content for people to look at, all that sort of thing, HDMI is still a very crucial component. And again, referring to the actual connector that goes in the back of the display here. So now we need the idea of, I've got all this good stuff. It needs to go into an HDMI cable and connector so we can get in the back of all the millions of monitors in the world. How does that happen? Where does that take place? So that's our segue into the last of our topics, and that is that we now have products and switchers that allow us to do that. So, for example, and this is the self-serving part because we're Panasonic, we make switchers about this. We make a product called Kairos, which is a super cool switcher that is designed to work at every level from AV-based corporate applications, houses of worship, broadcasting, the Olympics, high-end sports, all that, everywhere in between. At some point, people want to output not only a signal that has got all the benefits of IP and we'll say 2110 and all that, but I need to get it into some kind of a box that has an HDMI connector. So we have boards that are available to take in signals with HDMI, output them via HDMI as well. Again, talk about the physical connector, except that the whole IPMX world goes with it. So now we have the ability to take in the super high bitrate 12-bit, we can do the 444 signals, and we can set our own resolution, knowing that a video wall, because if you think there's a huge collection of standards for commercial displays, then imagine video walls, which no two of which really ever the same, because you can build them up on a tile by tile basis. So again, there's not even a known standard there. So you can dial in the exact resolution of your wall and output just that amount of information, no more, no less, using the IPMX interface. And ultimately, it goes out over an HDMI cable, plugs into the back of the box that drives the wall, and all is well in the world. So that's one application, driving video walls, but others are going to just plain old displays that you'd get off the shelf. And again, the HDCP and the EDID and all of that basically funneling down this wonderful HDMI cable that we all know and love back into the display, and away you go. So being able to bring in IPMX into a switcher, create IPMX inside the switcher, like the Panasonic Kairos, and spit it out over the interface that is so common in the world, HDMI, is a super cool way to blend the technology that is present everywhere, the connection on the back of a display, for example, and the latest that we have in the world of networking and AV and broadcasting all together, and getting, once again, my analogy about the Reese's Peanut Butter Cup, the best of all the worlds. Okay, so that is the end of my official presentation. And at this point, I wanted to officially open it up for questions. I should have pushed one more button there to say we have the HDMI interface. So that's the end of the presentation. And if we have time, we can kind of go through a quick demonstration of how you'd actually go and set the resolution for an output, for example, using our switcher Kairos. I know we had talked about in our prep for this call, we wanted to leave a certain amount of time for Q&A and all that. So we'll leave it open to the group here if we want to take a quick look at that demonstration. I'll stop sharing my screen for the moment so we can prep for that if it's so desired. All right, so just now, I guess, soliciting questions.
So Atkins asked if you were building a large facility, and Atkins, I'm assuming this is some sort of broadcast facility since you're mentioning SDI. What would make you choose IPMX versus SDI? In other words, how mature is it? Well, it started 5 years ago, but what are the products?
So great question. If we think about in comparison, say the SDI and HDMI, which are pervasive and everywhere, 2110 is come a long way in just the last few years. But likewise, because it is the newest kid on the block, IPMX probably is the fewest amount of manufacturers supporting it. Now, because it's got a lot of great benefits, more and more people get on the bandwagon every day, but certainly not as ubiquitous in the world as 2110 or SDI HDMI is. So it's getting there. We expect it to fully be something that everybody uses in the near future and certainly long term, but not a ton of manufacturers make a ton of products at this point, just because, again, of that newness. As you might know, when something is invented, it takes years for people to eventually develop products and create them and spit them out and that sort of thing. The same thing happened with every standard that's come along. With SDI, it took quite some time for people to get on board and start making products. But of course, now they're the standards. We expect the same thing to happen with IPMX, but I wouldn't say you'd see a ton of IPMX support just yet, because again, it's so new.
Yeah, we kind of saw that in the HD-based TV, right? When it was first adopted, it was kind of everybody adopted their own. Sometimes there was a poison pill. I haven't heard of that in the IPMX standard of any kind of poison pill where a manufacturer makes it so theirs doesn't work with anybody else's IPMX.
Nor have I heard of that at all. So we'll say that's good news.
And then Davis posted about NMOS being the open standard. Want to talk a little bit about that control protocol?
Great point. So NMOS is a way that allows, generally, there's different applications for it. Probably the most common application would be I'm a router, if I could anthropomorphize the situation here, and I need to send my streams to a variety of places, for example, a switcher. And again, just because we've been talking about it, I'll mention Kairos of late. A switcher might have a lot of inputs, 64 inputs as an example. And again, they all have IP addresses, and those IP addresses are unique to video and separate and different for video and separate and different for ancillary data times 64 sources, and not to mention the destination. So if you were to go and manually change IP addresses for the different streams, that could be a little tedious. So what we want is a standard to exist that allows, for example, me, the router, to reach out and put my hooks into another device, such as a switcher, and then not only have the ability to change what it's subscribing to, what that switcher is looking at, what IP addresses it's hoping to see, and automatically change that, but it can change them all instantaneously. So as the router, if I support NMOS and I reach out to a switcher like a Panasonic Kairos that supports NMOS, I could reach out to it and change all, gosh, what's the math on that? 3 times 4. All 200, we'll say, IP streams instantaneously. So no one has to go to the switcher, such as a TD, and manually type in 246.53.12. That would be, impractical, to say the least. So a router with a set of commands, typically called a salvo in the routing world, would push one button and it would tell the switcher to subscribe to all these streams. And if you think about that as a display or different products that basically receive signals, NMOS puts its hooks into them and says, I want you to subscribe to this signal and take that stream. And that could be for video, audio, ancillary data, all those things. So NMOS is a big part of higher end 2110 facilities where, again, you want to be able to have people subscribe to streams. When I say people, I mean switchers and displays and things like that. And do it instantaneously with a minimum effort on anyone's part. So it would be great, since our new best friend, IPMX, is part of the 2110 world, if it also supported NMOS, and the answer is it does. So if you want to use NMOS to essentially put its hooks into various display devices and things like that, or the receivers of these things and tell it what to subscribe to, it'll do that for you. So NMOS and IPMX are definitely best friends, just like 2110 and NMOS are best friends. Oh, and it's worth pointing out that I glazed over it a little bit before, but in the 2110 world, essentially PTP is a requirement. You have to have some reference, if we think of it in the standard SDI world, to make sure everything's in sync. For lack of a better phrase, in the 2110 world, you need precision time protocol to make sure everything's in sync. But if you think about HDMI, it's like, oh, there's no reference there. That makes my life easy. I just have this one cable, no reference, yay. And once again, in the IPMX world, you don't need the PTP that you would in 2110. So one of the benefits of IPMX is you are relieved of the requirement to use PTP. So if you don't have an expensive PTP generator, if you don't want to have to configure PTP, you don't need that in the world of IPMX. If you want it, IPMX supports it. So super cool. Just like NMOS. If you want NMOS, it's there for you, but you don't have to use it in IPMX. If you want PTP, it's there for you, but you don't have to use it in IPMX. So there's lots of flexibility in IPMX. A lot of people have phrased it as it's all the great things about 2110 without quite the draconian requirements that 2110 saddles you with. So IPMX is, we expect once again to be very popular because you can still use it, still get just about all the benefits, but not have to be quite so precise about it. So nice things about NMOS, nice things about PTP. Use them if you want. Don't if you don't want to when it comes to IPMX.
Now's your chance. Any other questions for?
I've got another one. And Keith, you could respond even, with Panasonic as the context, but are we looking to a future, and if so, how far away do you think, where our source devices like, cameras or potentially even computers are outputting IPMX and our destination devices like displays and projectors are accepting IPMX directly? Because, for instance, projectors, they, accepted HD base T pretty early, but displays have never gone the same route. So curious what your thoughts are there.
Boy, great question. So I don't know that I have, I guess we'll say, enough insight into it to make even a prediction. Um, I like to think because it's evolving pretty quickly that, as I just mentioned with, PTP and NMOS, used if you want, don't if you don't, that'll be something that's worked into it. Um, but boy, I'd be loath to hazard a guess if we'll say we're headed in that direction. Um, just well, a bit out of sheer ignorance of all the different aspects that are involved and whether or not it's practical or not. So I wish I had a better answer for you. The best I could offer is it certainly seems like it'd be possible to do that, but whether or not it's actually implemented, I don't want to say who
Yeah.
knows. Maybe someone smarter than me knows if that's the direction we're headed in. But yeah, sorry, I don't have a better thought than that.
Is there a fairly hefty processing component for the encoding and decoding of IPMX? Like, would
And
that be
that's
a
the
hurdle?
oh, forgive me for interrupting there. So for the most part, no, because again, and I should have brought this up or hit it a little harder at the beginning. Um, IPMX, for the most part, isn't about a codec. It's not, in fact, it is not in any way a codec. So you don't have any real processing. It's just a wrapper or a transport mechanism is really a better way to say it. I should put it that way. So in other words, most people use IPMX today in its uncompressed format. So all you're doing is putting things, encapsulating the streams, and de-encapsulating them, as the phrase goes at the end. So there's not a lot of effort that goes into it. So the processing overhead and all that you're mentioning is almost nothing. Hence the low latency that we enjoy with IPMX and 2110 in general. So for the most part, not a lot of heavy lift there to make IPMX work. Now, if you start getting into the compressed options that exist within IPMX, JPEG XS, and there's some other ones in there, then of course, yeah, there's a whole process that goes into compression and decompression and the effort and time, then latency that goes into that. But into IPMX itself, not much.
Okay, thanks.
And it's a extension of that concept that I probably should have hit it harder as well earlier. So just as we mentioned, where in the 2110 world, PTP is essentially a requirement. And you think, well, that's great. I get to use these commercial off-the-shelf switches as opposed to expensive routers. And of course, say, well, you have to get a switch that's PTP compliant. It's like, oh, great, so much for inexpensive switches. So the cost of getting a PTP compatible switch is, takes up a notch, and it's like kind of a bummer that you have to buy one to make it work in the 2110 world. But if you're in the IPMX world, which doesn't require PTP, you can go through switches that don't support PTP. So it is kind of a cool thing about the IPMX world where you can use less expensive switches. Obviously the same data rates are there, the 10s, the 25s, the 40s, and it's up to 100. But it doesn't have to be a PTP compliant switch for the world of IPMX. So just thought I would mention that since we were talking about some of the capabilities that are required and the lift to get things into the IPMX world.
And then Abraham asked if it still utilizes multicast, although it doesn't need the precision time clock. It still does need IGMP, right?
So yeah, multicast is still a big thing. So we'll say that's where it's part of the 2110 world distinctly. So the individual streams, the multicast addresses, as you're saying, all that stuff is the same between IPMX and 2110. Yep.
Still got to calculate your lags, which we talked about in an earlier session if you're doing multi-switches, and then you still have to work with the IT department if you're going to put that switch on their network.
Yeah. So let's see, I'm going to show one last thing, just sort of in practical nature, if we have just a few more minutes here. So this is the interface of Kairos, our switching system. It is essentially, as we mentioned before, something that's great for AV applications, corporate, religious, all the way up to high-end sports and things like that. This is the output settings page. And so here's our various ports that we have available to us. I'm going to go over and say, here's my output, my choices that are available to me. And look at this. I have all the usual suspects, the 720s, and all kinds of other cool things. And there's a handful of the more recent additions in the display world. So a lot of choices there. Yay, that sounds great. But what if I have something that is a complete oddball, maybe a video wall and things of that nature? It's like, oh man, that's not in my drop-down list. I'm not going to find every resolution of every video wall ever in my one drop-down list. That's just impractical to think that would be the case. So wouldn't it be cool though if I could say, yeah, thanks for your list of things that usually help me out with displays and recorders and other products down the line based on a limited set of standards that exist in the world. What if I want to make my own? So you can go to your little pencil here. I'm going to go to this particular place, user number 2, and say, all right, I want to make myself a standard. Here's a basic one that we all know and love, but my video wall is this width by that height. I'm deliberately coming up with a wacky number there. All right, so now I can say that I've got this exact resolution going to my wall. I don't want any more. I don't want any less. I just want that exact thing. And now I can go down here and I can choose the exact frame rate. Maybe it's 59.94 or maybe it's 60.00. And then cool thing is it's a pretty nice wall that it has more of a color space, RGB, and then it's also a 12-bit. I've got some other options there. And then I can go ahead and save this. And now I can go to my drop-down list, and there is that super cool thing that I just created. So now I can output exactly that in the IP world. And that would go, in some cases, to my overall infrastructure, back into the switch, all that sort of thing. Or maybe it goes to, at some point, my HDMI output board and all that. And now I can go and derive that wall, that display, whatever the analogy you want to use, with those exact set of specifications. So I'm not tied into the standards like we would normally think of as the traditional world, whether it be 2110 or SDI or all that. And now I can be precise about what it is I want to output. And likewise, within Kairos, I can create my own operating environment, my own canvas, if you will, that matches those specs exactly. So again, I'm outputting exactly what I want, no more, no less. So just wanted to show you a practical example of how we could utilize IPMX in the world, where you're not forced to be conformed to one standard or another, but you can make your own connectivity based on your exact video wall or device or whatever it happens to be. So, wanted to give you a feeling for the ease of use. Quite often we think about, boy, it's super complex and all that stuff. It doesn't have to be more complex than simply dialing in the information that exists for, in this case, your display. Now, of course, at some point I would need to put in, if I'm putting it over the network, I'll need to put in my senders, the address of it and all that sort of thing so that it could be subscribed to by other devices down the line. But short of that, it really doesn't have to be complicated. And in fact, it's super flexible and easy. So wanted to make sure we all had a chance to take a look at IPMX in action, at least in this limited context here.
So Jacob asked if there's a limiting factor for that software, total number of pixels or dimension, if there is one.
So great point. Of course, there's always limits in the world. So if we're talking about Kairos, the concept is you have the ability to output what we refer to as a canvas. And of course, there's always a practical maximum to something, but it's 66 megapixels. So if we think of, just a couple million pixels or being an HD image, 66 would be an awful lot of HD images. And of course, it can be in any configuration. If you wanted to have it be like a ribbon, or if you want it to be super tall and portrait aspect ratio, or in between, you have a 66 megapixel bank that you can borrow from to create these different things. And you can have one gigantic one that's all 66 megapixels, or you could have 5 different ones. One's portrait, one's ribbon, one's square. And you, as long as you don't borrow any more from your megapixel bank that you have available, which is 66, then you can have as many different unusual aspect ratios as you want.
And then Davis asked, if a source is destined to multiple destinations supporting different rates, do I need to create a source to match the destination? I guess when in reference to resolution. So if you were doing a 720p monitor, would you have the source be 720p, or is the scaler on the decoder?
I guess it could be either. That would come down to the actual product. If we're talking about Kairos, then it can do the decoding for you. So you have, let's just say, you're doing a 1080 show, and you've got 10 different outputs and 10 different monitors. Then Kairos can basically make a different resolution and frame rate for each of those outputs. It'll do the scaling internally and spit out something that just that one monitor wants on output 1, a different collection of stats on output 2, so on and so forth. That's something unique to Kairos in the Panasonic switching world. I don't know if everybody else has those capabilities. I think there's probably not too many that can output a different resolution and frame rate for multiple outputs, but one of the feathers in the cap of Kairos, if you will.
Awesome. Well, we're right at the top of the hour. I want to thank everybody for joining us on this Friday. Our next one comes up in a few weeks, so go sign up for the next item on the web series. With that, signing off.
Thanks so much, everybody.